Okay, welcome to the stream. I'm going to pick up where I left off yesterday. This is, I'm working on another learning Python here, and trying to make a maze solver. That's what this window's up, but I'm not going to do that today. We're going to open the audulus canvas. There. Yeah, well, I can shut this. There we go. Okay, so yesterday we made a background class that allows us to do this nice gradient here in the background, and we're going to further refine that today. First, we get to make this a singleton, and what that means is I want the gradient background, or I want you to be able to create only one background, because as it is right now, you could create a second background and layer them on top of each other, but that doesn't really make sense, because you should really just have one background layer. And then say if you wanted to change what the background looks like, you directly alter the attributes of the background, but you don't want to have two of them. So we're going to make it a singleton, and there's a way to, on object creation, basically check if this has been created before, and if it has, it just says nope. I'm going to throw an error and say you can't make two of these. And so rounded corners or no, we're going to add the option to create rounded corners, because you could have rounded corners that match these ones, like this, or rounded corners or straight corners that just go to the edge, like that, but like a modular where you have like a square panel. And then inset from the line versus covering. I actually think I'm not going to do this because we're going to keep there's a little tiny edge around here that is the groove of the module, and I was getting confused because actually when you select a module, there is a little kind of emphasis line that goes around. And I'm looking at this really close, and I think for some reason it might just be an optical illusion because of the different colors on both sides. But this side over here looks a little different than this side. I'm going to do a keycaster. Forget it. I think I press the keys so quickly that you probably can't even see the commands that I'm doing there, so I don't know how useful that is to you guys. Okay, so first we're going to do the singleton thing. Okay, I'm going to go inside here. So work with the canvas node directly. And if you're new to the stream, like I'm sure a lot of people are, basically I have all of this code here. This is the whole library of code. You can see there's, a few thousands of lines of code. And if you scroll all the way to the bottom, this is where you actually write the code right here that you're using. So right here, this whole thing, even though I have all these thousands of lines of code, this is all we're really doing right here, is creating a new background. I actually have there's a shortcut. You can type B for background and like G for gradient, and these are the same things. If I do T gradient, that doesn't work. If I do gradient, then that works. But this is just a way of making the code a little more concise and easier to read. So you have gradient, a new between two vectors, 2 points, like negative 100 and 100, and then color, red and blue. And then we assign the gradient property to G of the background, and then we draw it. That's all the code that's going on, that's actually actively going on. The rest of this is function definitions that even though they're there, like, I'm not using, the graph class, for example. Right? So that's sort of what a library is. You have all these available functions, but you don't have to use them all in any particular instance. And what I'm actually going to be doing is, at some point when, say, you've created your, like, all I want to do with this thing here is just have this background, and I don't want to have anything else in here that isn't related exactly to what this background needs to render. And I will create a little, like, command line program where you can have your code file separately. So, like, I'd just copy and paste the, well, actually, you wouldn't even need to copy and paste. You could just copy and paste this code, and in a code editor or something, you do like my code Lua, and you paste this in, and you open up this Lua file in a command line, like basically a little program that runs in this area, that's terminal, and you'd be like Mark's tree shaker, and then dot my code Lua, and it would automatically go through all of the code that's in here. It would look first here, like, okay, what do I need for the background? What do I need for gradient? And it would delete everything that is unnecessary for rendering this background. And so you'd end up with much less code here, which, for one, it would just make it a little easier to navigate. It would also make the file size a little smaller, because imagine you have like 20 modules here, and they're all just replicating the library code for the whole library, which will be even larger than it is now, like probably closer to 10,000 lines of code. And you're just replicating that unnecessarily, so this saves on a little space. And I mean, it's not. This is a timer. You have a timer node that's wrapped up in here. All it's doing is counting up, and this is actually using less than this little module thing here, right? So you're not really saving on CPU because this is so efficient to draw, but in some sense you would be also saving on CPU, because then it would have to be redefining all of these functions in different areas, because the scope of the library is localized to this one canvas node. You can't have it's just too complicated to have like a centralized node where you deposit your library code, or like a little panel or something that then would be available to all the other canvas nodes. It's much simpler implementation in the backend at Audulus to just have each instance of the canvas node is another instance of like a Lua script running, which is okay for performance. So now that we're going to get through this, I explained all of that. I'm going to delete this. Okay. Now we're going to make this a singleton. So what we need to do is add a property on background, which is created, and we're going to set that to false first. So where should I put this? I'm going to put it there. So self.created equals false. Wait, it equals true. Oh, this is confusing. Yeah. Hold on. Yes. Okay. Yeah. We have to set a class property first. Okay. So we need to do background dot created equals false. Right. So we're creating a property. A background is just a table. It's just, you see right here. So it's just a table, and then you can add things to tables like this. Right. So I'm background.id. I'm creating a new member of this table, a new item in this table called ID. Oops. And it's the same thing as like adding, like doing like table dot int insert, and then you do like the table, some background, and then something here that you want to insert to the table. And I'm doing background.created equals false. And so, yeah, we don't need to do this. So we're actually going to go here. So the very first thing it's going to check if it's created. So if background created equals false, or equals true, then error, one instance of background is allowed. Okay, and then we're going to set background.created equals true. Here. So it starts off as false. The first time you create a background, it's gonna check, have I been created before? Has this been created before? If it's true, then you're gonna get this error. But since it's the first time, this is false, so it skips this, and it goes down, creates it, and then we set the background.created as true. So that the next time that you go to create another instance, then it won't work. And I'm pretty sure I did this correctly right off the bat. Let's see. What did I do? I was pasting over the wrong area. Okay. Okay, so let's do b2 equals b.new o. Yep. Let's see, it immediately, there's only one instance of the background is allowed. So we're not able to create another background. Okay, great, that's perfect. That's all we needed to do to make it a singleton. Okay, rounded corners or no. So we're going to add the ability to I wonder, should we do, I was kind of daydreaming about this a little bit, if it'd be fun to have like little screws on it. I think that's something I could come back to. You know, you basically have like a square panel like this. Let's delete this. You'd have a panel like this. Hold on. Make it the straight line. So panel. Oh, that snaps to the, that's cool. Nice. You have a panel, a module panel here, and then we could have like little fake screws in the side, like they do in modules. And I could even add some logic that would check based on how wide it is, right? So like if this is a, you know, this sort of looks like in Eurorack standard, maybe like a 16 HP module or 12 HP. And then if it was smaller, then it would detect that it's at the size where you just need two, you know, up and down. Like if it was like here, you could have a module that has just one screw like this, like in a 4 HP or an 8 HP module. But that's something I can add later. But that's interesting. Yeah, as a thought. But what I want to do is right now is have the ability to make this a square, or kind of have the rounded sides. I'm exaggerating it there, but the rounded sides to the module. And I'm wondering, does it matter? I mean, again, you're trying to make a library that does everything that you could possibly want. Right now, I think I'm going to constrain myself to just like, okay, is it going to be like this or like a corner? Because I could see a possibility where, because you can do this, the module underneath it really is just sort of a suggestion. I can put that outside of the module, and then now this goes with the module, right? So the module is more like a kind of just a place to click on to go inside of it, and it doesn't even really need to be the same size, because for example, I could just do this. I could hide the module inside, so we do 10 and 10. Right, so now the module it's inside of this thing, but the problem is I can't click it until I get down to this little tiny thing, which is where the module is. So you're moving it around. So the module is basically right here, but you can't see it because it's covered by this. But it might be fun for people. They could make a circular module like this, or and that essentially you have to click like somewhere in the center of the module. Let me go backwards enough to, did I say? There we go. Hold on. There we go, okay. You could make a circular module like this, and you'd still need to have the module, be square, the like module node be squared underneath, but then you could have a fun shape that's like maybe like a line 6 pod like this. But for now, I'm just going to do these two options, of rounded corners or straight corners. I'm gonna move this up here. Just keep everything kind of organized. Let's say permitted. That sounds more official. Permitted. Then, okay, what we were doing here is the corner radius. So we're actually going to set corner radius as we're do like self.rounded. I'm trying to think of like what to call this property. Self.rounded. That's true. True or I don't know. Oh, okay. Self.options.rounded or true. Okay. So we're going to first look and see if it's defined on the options as we are declaring the background, or we're just going to set it to true automatically. So by default, you're going to get rounded corners, which makes sense because it would map to the module as it is already. So if self.rounded, let's do rounded. Let's just do rounded. Okay, if self.rounded is true, no Python there, with the colon. Let's declare local.corner radius, and then corner radius equals 6. Wait, actually, hold on. I don't need to duplicate that. So, wait, not do. Yeah, if then corner radius is 6. Okay, else corner radius equals 0. Oops. Go inside. Okay, now, so obviously by default it is true, but then let's do b dot rounded equals false. There we go, now it's square. But again, we're not going completely to the edge, and we'll fix that in a second. So I'll do AFK, be right back. fix this somehow. Okay. So, okay, no, when it's square though, we want it to cover this edge because that looks weird, right? So actually, I do this. I'm going to go x1. Can I just do this? y1, x2, y2. Can I just declare all of these like this? I think that's much more concise than doing them on the same line. Okay. I'm doing them on different lines, that is. So in one line, I'm just initializing these local variables. And the reason I'm doing that is because I'm within, it's not good. I think it's, you can't do this, right? I'd have to check this condition, and you don't want to redefine this local one, right? You want to define the variable in one place and then change it later depending on a condition. Then you want to initialize the variable like this. So in the rounded corners, I'm going to put these ones. And then I'm going to take the local keyword off there. Whoops. Again, I just need to learn Vim movements. This would be so much faster. But I will do that in another stream because I'm painfully slow at them. Okay. Self-set is true, and then okay, so that's false. Then we're square, and then we're actually going to 11. I think 11 worked the other time when we were doing this. And I don't know why this needs to be 9. It doesn't make sense to me. We're gonna try that again. Okay. Okay, there we go. So you can move the module around, but you're not getting any visual feedback that you've actually selected it like you do here. But I guess that's okay. There's no way around that. Okay. Now. Okay. Takes a second for that to load. This is interesting. Why is it like this? The custom is 60 to 350, but then it just has a, I guess when you set a module to a certain, that's interesting. I guess, you would expect, no, because here it is. I think because you have this hard edge on this, and it doesn't make sense to kind of match it up there. I don't know why. If this is set to 60 and 350, and so is the module, why is there space between these two? It must be that there's just a padding along the outside of these things, or there's padding on the module. That is, like the module node has padding versus the size that it is, which makes sense. So, so, okay, what next? I'll go down here and do the around is true. That looks okay, but we're covering up one of the sides on that side. That was from what I was talking about before, where, is it possible? Is it possible that the module node is weirdly kind of oriented. That like it's, if this is directly in the center, that maybe like it on the module node itself, it's the wrong dimension on this side. Because what's the explanation for this? Why if I'm getting the corners, right? Because what we did yesterday is you have an origin point here of the module. Come on. So we have this origin point, and it can be anywhere. It could be here, 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 here. That's the origin point of the canvas node, actually. So then you make the canvas node the size of the module, and then this is supposed to then extrapolate and find the corners of the canvas node. And then in the background draw, we're finding the corners of the module that is set to the same size as the canvas node. But for some reason this isn't even on both sides. You can see how this looks good going around this side, but then when it goes around this side it's a little too long, which makes me think that maybe it's an off by 1. No, see, and actually it's not up enough over here too. Okay, let's just we'll just adjust this manually so that it looks good. This is probably, so this is up by 1, so this is the x1 or y1, so minus 9. That was what we were doing before, and then this x will be minus 9. I think that'll fix it. Okay. Oops. I'm doing Command E to edit that, so I don't have to go inside of the panel. Now see, yeah, it's not matching exactly, so I think the corner radius is off. This is odd. I might have to talk to Taylor about this, like why this is happening. Because you see it's just off like just by a little sliver here. I mean, if you're on a phone, you probably can't see this, but it's enough. There's a visible edge in between this highlight line and this. So that's like a point something that it's off by. Let's do, for the Y2, which is up here, we're going to do X. Is the X off? Whoops. Yeah. Oh, I wish I could zoom in a tiny bit more, but that's a little excessive. So we want the first XY pair, which is over here, to go down just a little bit. And so we'll do minus 9.1. This is such a tiny, tiny minor detail, but it will be worth it, I think, to just look a little nicer. That's better. 9. It's like 0.2. Sometimes programming is like this. You just have to wait a sec. It's weird how, like, if I press it here, it takes a lot longer for that to show up than if I go inside of the module and then click on the node itself. Okay, so almost there. Let's do... You know what? Well, when you're doing stuff like this, it always helps to overshoot, and then you can kind of see how much you've overshot it by. And yeah, because I think that's too much, right? Oh no, that looks good. Maybe 9.5 is it? That is good enough. Good enough for now. Yeah. Like, at least from farther away, it looks... on this edge, though, it kind of... Hold on, I'm going to set this to a solid color so that it... I think I'm being a little influenced by the gradient when I'm looking at it. So, for a second, let's just set this to red. That's a little intense, actually. Hold on. That makes it even harder to see. Let's do blue for both of these. I can just easily set this back. I'm just comparing how the line thickness is. Obviously, this one's line looks a little more bold because it's still overlapping this by a little bit on the outside. I don't know. Maybe this is something I can just talk to Taylor and get the exact specifications of like how many pixels or units or whatever the module is inset from this, because my guess is, you have this line that is the outside of this module, and then you have a thickness of this, which is probably some integer, probably 1, and then 0.5 comes in and 0.5 comes out. So to illustrate that, you would have, you can imagine this is a cross-section of the line if you zoom in really, really close, right? So then the line of the actual module is right here. But then half of the line that gets drawn as this emphasis line is on the inside and half is on the outside, rather than it being on the outside of the module. And that just makes it so that the module doesn't sort of grow so much. Visually, it would grow if it was on the outside of the module and then you got added onto it, so then it would kind of jump up and look bigger. And then if it was on the inside, if it was drawn totally on the inside of the module, then the module would look like it shrinks. So if you just do this line where it goes exactly half and half, it looks like it's just being emphasized. But then that leads to, if this line is an integer and not something that is easily divisible, then that's why I have to put this 9.5 there, so that it is accounted for that. But I don't know why it's uneven. That's the thing that's tripping me up a little bit, is why is this uneven from one side to the other? Yeah, okay, we won't worry about that. So I think this works. Let's just try this again real quick. I keep pressing this option key is the key you need to move to pan in Audulus. But then evidently, if you're in a different window and you focus, and you press option, it'll minimize, that window. Okay, so then false. Okay, cool. I just want to see what these look like real quick when you have a couple modules that are together. We'll do this red and blue. We're going to line these up. Yeah, you can imagine like having a whole bunch of modules that are together like this. They look like more of a, I don't know, more of a module, I suppose. Right? Like a not more of, just more scalomorphic, like how you would see modules there. I can understand why things are rounded here. Like that makes sense as a design choice, but this is just a fun option that you now have to be able to make them look very square. Okay. Rounded corners are no. Inset versus from the line versus covering. I think that's a little finicky. I had that from before, but actually you don't want that on the rounded because this is giving you the select. Yeah, so we're gonna skip that. All right, background is done for now. No, but I need to make the print. I'll do the print method later. That's less interesting to program. The print method is just a debug thing so that you can check out really easily, nicely pretty printed underneath the module at in the print output. You could do like new print like that. Like that creates a new vector in one line and then prints it. So then you have this nice, pretty printed version of what you have here. These numbers here, this means that this is the 14th element, like 14th element that's being created in here, and it's the 8th vec2 of that. So you have, if you add up all of these vectors that are drawing in here, because I think you have 4 here, and then you have a vector for the origin, and then vectors for the gradient. Then those total up to 8 somehow. So that's of the class and of the elements total, and then you end up with a unique identifier for every single item, which can help sometimes in debugging. You know. Okay. Got that. That's done. Add a method to force origin to stay on top. That's going to be a layer thing that we do. Yes, fix required, but we're going to do a little fix here. Okay. Because the way I have this structured right now, this direction actually should be optional, I think. Yeah, so, and we're actually going to rename, we're going to rename this symbol to options just to be, before I was trying to be a little clever and just have a shortcut version, but I think this is a little more explicit. I don't want to do this stringed out lower. That just seems... Actually, no, is that nice? Because then some... No, I want people to know that you do properties lowercase, like... Yeah, so... self.options.type. Yeah. Because we want to point to the self options now. I mean, there's only going to be one of these two. That's another thing, actually. So make a singleton. Make a singleton. Okay, we're going to make this one a singleton too, because you should only have one origin for. I could possibly see some. No, I really can't. I can't see any reason that you would have two origins on a canvas node. So we're going to make this a singleton as well. We're going to do self.direction equals self.options.direction. And then yeah, let's open this to the side because we're doing a pattern here that I want to replicate. Index. Do we need this? I don't think we need this because we're not doing this stuff. Because this utils.resolve property helps with these defaults and when you're going between different styles to resolve the property from this table. But if if we're just setting some kind of defaults, that, because basically, you know, in the line, you don't want to have a line instance that has all of the properties for all of the different variations of the line that it could possibly be, because you're just wasting space and cluttering the object with all of these unrelated properties. So what this does is it goes through, and when you set the style on the line to one of these things, then it goes and it gets these things from there. Yeah. Okay. Let me close this for a second. Give me a little more space here. Okay. Translate self to offset. Yeah, I should just refactor this a little bit to be a little more organized, because I sort of started this one. Should I do this as a dot? No, that's okay. Because we can also change the origin type. For now, let's delete this stuff so that we can focus on the origin, which is up here. And this is sort of set in the default code that I'm kind of copy and pasting in, and then this is the other code in between that we're writing, assuming that we're always going to have an origin. You don't technically have to set the origin, but it's useful to for debugging purposes. Okay, so local options equals self.options. That's what I was forgetting. Self.options equals options or this. Why is it complaining? Directions. Why is this complaining? Oh, because it's I can't make it local. I have to do it like that. Yeah. There we go. You can't make the self property local because it doesn't make sense to have it there. So direction. So self.direction. Direction. Okay. Oh wait, I just that was a leftover, I think, from there. Right. Yeah. That was left over from when we were originally doing this. So, that was getting in the way. Separate this. Offset, we're gonna rename this symbol because it's a hidden property. Not show or false. Where's the offset? Wait. Where do I use offset? Yeah, there. Okay, so this rename property, this thing doesn't work very well when you have self, because I have to do that there. All right, self.offset. This is the offset from that we're adjusting the origin by when we're shifting the origin. We're actually shifting the whole canvas around the coordinate system that underlies it. And you can set a property. It's just signaling. This doesn't do anything special behind the scenes. It's just signaling to other developers who use this. This property is meant to be private to the instance of this origin class, because you're not supposed to manipulate this directly. You're not, you don't want to be able to do origin like o dot offset equals something, you know, because it's calculated from the direction there. So I think this is good. Though, okay, we want to have color only mean instance of a color class, so we're going to make that. Maybe I do want this because did I do that on background? Because I think I need, now that I'm looking at this, I think I need, yeah, the resolve property thing. To do utils.resolve. Oh, I don't have the chat up. Hold on. Okay, just in case. Dot resolve property. This way I could set the color like this and do these with assign options. Because if these were just truly optional, then I would be able to do assign options right there. But they aren't optional. You need to pick all of these. So we're doing them explicit there, but we want to do this assign color thing. And instead of assigning the color as a color table, we're going to assign it as a color object. And then the local paint equals I mean, I don't want you to be able to putting a gradient on the origin doesn't really make sense, but I guess you could just let people do that. So local paint equals this, and then that should work. Because this color.assign color will look at the options and then assign the color if it's defined, or if it's not defined, it will default to a like a text-based color. Okay, yeah, what went wrong here? Let me delete all this stuff. Actually, get this outside of this. Do that. Okay. So, bad argument to lower. 789. What is that from? Wait, no, that's not right. Yeah, of course. 789. Is that right? Are these line numbers drawing correctly? Hold on. 789. Okay. Yeah, because I didn't change that self.lower, so direction. Self.direction. Wait, that doesn't make sense, because if I did, hold on here. This is calculate corners is okay. The error is on, not on this line. Offset, origin offset. What part of this? This is calculate offset. Direct. direction, so calculate offset. Where am I doing that? Why isn't that working? Oh, it's offset option set direction. Yeah. No? That should be right. Okay, I'll be right back. Okay, I'm back. Right. Debugging this. Better to one lower at 789. Local offset origin. Well, we don't need to call the string.lower there just because that's a bad place to do it inside of this function. We should do that at... Oh, wait, what is it? Yeah, no, I don't know why. Okay. Calculate offset. So what this does is it takes a direction and then it looks the direction up in this table. And then it gives you these offsets and then returns that as a little table that you then use later here. So it's offset 1 and 2, so it's like 1 and 2 is the offset. That's in the reset, that just kind of, that puts it back. So, is this gonna work? Probably not, I don't know what I did before that's different. Yeah. What? This is a totally different value. Or a totally different error. Attempt to index local t a nil value. So where is t? Whoops. No. T a nil values with sign corners. Why is that a nil value? Oh my god, I have to set direction or C. Yeah, or C. I forgot to do this. Oh, I'm gonna have to change this. Yeah, I have to change this in. That's why I'm gonna change this in the shell script because it is defined there, and this is no longer a required argument; it's an optional argument. So we're gonna go like instead of direction. What do we do? Like I don't know. I guess direct. I realized I was having the same thought the last time I did this, which is, should there be a better name for this? And there is not. So even though we're going to default to C, within here, I just want it to be explicit for people, so that they know you can go in here and just edit these real quick, rather than if you want to like put them in there. Ooh, the color. We want to take the color off. Right? No, because we can leave that like it is. Right? Can we? I forget if assign color. Hold on. How did I do this? I think that's fine. There we go. Okay. So now this is a option. And should we make this a little easier to read like this? Would that look nicer? I think so, maybe. Technically do that, but that looks, yeah. This. I mean, the spacing is kind of arbitrary. Go back to the build. No, do this. Oops. This is so every time now it builds, it will look like this. It'll be a little easier to read. Okay. Let's see if that did that. Okay. Yeah. Change all this stuff. It's not really too good alpha. Let's just say it's version 3. Whatever. I don't know. I don't know why I even began to version these. Okay. Oh, I'll change the date too. That's the 29th. 29. Okay. Required object resolvtions did that. And make it a singleton now. Okay. So origin.created equals false. I feel like because it's an object, we should do all these other things that we do. Where we're assigning IDs. Line.id, so origin.id. Origin.id equals. When I'm adding this extra code with these IDs to help with debugging, and when you use a tree shaker, it will remove all of these IDs because you don't need them anymore. They're just for debugging purposes. So even though this, because it's a singleton, you only ever have one of them. It's just for consistency to have them there. So what this does is it assigns this ID to this object, the first one you create, and then it increments this one, and it also assigns the element ID and increments that at the same time. But we're not going to use the we're not going to ever do more than one of these, but that's fine. So assign IDs. Do I need to assign options? I don't think I do, because all of the options are declared like this. There are no other options that are hidden from here like there are here. So, okay. And then we set origin dot created equals true. Oops, true. Then I'm not going to let you do this. Hold on, I'm going to open this a little bit. Separate the arguments here, the required arguments, from the options. I'm just trying to make the style consistent between different classes so that you have you create the self here and then you assign the arguments internally and then you go on to do what you need to do with that. So this is the only argument to this one, so then the rest is down here. You know, the more you make every function look or every constructor, every function kind of look the same, the easier it is to read as someone who is coming to this new. They would be looking at this code and you would at least subconsciously pick up on this convention where these the self is declared and then you declare the arguments, and then later in this other code block you're doing the other stuff with those. Yeah. Okay, and yeah, just to make sure it's consistent. So background creators true. I should do an origin.draw. Right, yeah, because the origin, we should separate this out. Because we could get rid of the show property if we have a draw function. And we could just do this. This is a remnant from when I was first doing that, and I hadn't even come up with a draw function for something else. I did origin first. Or one of the first things. So. Okay, so origin. Function origin draw. I have different names for these, but I'm wondering if that's advisable. Let's just do stroke. Yeah, I think I was trying to be clever here and give people an option to do stuff, but I think it's just better if there's one thing for each, then you don't have to, you know, let's do, this implies that it's the character that, so crosshair. People know what crosshair means. And we have to change this in the build library, so crosshair. Take out the show. Okay. Now that I think about it, there should be a length property as well, in case you are. Should there? I don't know. That'll be one of the things that people requested. We can make a larger crosshair here at the origin. So if you have some large module, and you can see it easier. But I think this is fine. Oh yeah, and then origin.draw. We have to do that. Oh, that's how we separate this draw function outside of it, and then we can manipulate that in the layer system, which we'll do later. But okay, yeah, because if it has its own draw function, then we can call the draw function later, and then the origin can always be on top if you want it to be. Good. This should go. Great. Let's do instead of crosshair, let's do stroke. Yeah. Stroke. There we go. Makes a little circle there. I just want to make sure this is working, so we could do color.red. Yeah, there we go. Theme.text, okay. Stroke. And then, what is the other one? Dot. Dot. Or point. Let's do point. Because that is lining up with the... No, dot. Because other things are dotted. Yeah. Stroke, dot. Fill. No, fill is like, what is it filling? It's, I don't know. Crosshair. Okay. Make a singleton. Did I make this a singleton? I think I did. No, I didn't do the check in the beginning. So, if origin.created equals true, then error only one instance of origin is permitted. Okay, let's test that. Okay, 2 equals origin dot new. Okay, cool. It would be kind of cool if there was like a defer, where you could, like how there is in Go, where you can defer execution of a function or something to the end of a loop, and I could just like send this reset down without having to do that. But who cares? It's explicit. It makes sense. Let's actually, no, because this is, to make this a little more explicit, there's no reason to do a shortcut there. Whoops. Let's just do origin. Origin, and then origin.draw. Just so people who are kind of new to this don't have to like think about this too hard. So it's origin.reset. Print all. There we go. And then, what did I do here? Yeah, origin. That's what I thought. Okay, reset. I was saying a nil value, and then I realized because I had changed this, of course. Okay, print all. Great. Cleaning up little chores. Made a singleton. Okay, add a that'll have to involve the layer class. You know what? I was thinking, I'm going to need to add z-indices to everything that is drawn, right? That makes sense. I should do that. Put it on my to-do list. So z-index. So I did this. Add z-indices. Indices. Okay. The z-index is going to determine the drawing order of each object later on when we get to the layer. But we're just going to go through and add those to each thing that is drawn. So we don't need to add it to the vec2 because that's not ever actually drawn. You don't see it, but you do see point. So I think all we need to do here is just add, we'll do that first, self.z.z-index equals 0. Oh wait, no. Options dot z-index or 0. I think this is the only line that we need to add to all of these, and then we have to add them to the print debug statements too. Let's just and then add z-indices. Add z-indices to print statements. Just to keep track of that. That's the this print thing here. Okay. Print z-index equals z-index. Okay. Z-index equals space that for test spin. P equals p.new. Oh wait, no, we can just do the shortcut. P.new dot print z-index. Okay. Okay. The background needs to be negative inf. Okay. How do you do that in, how to do negative inf in Lua? I forget. Negative math.huge. Okay. So self.z-index equals negative math.huge. Okay. Is that a function? Yeah, okay. Because the background is the background, there shouldn't be anything else underneath it. So z-index is going to be math.huge. Ooh, that's actually interesting. Can you do +1? Can you do math.huge +1? I'm trying to make a z-index system and wondering if we can determine the background as negative math.huge, and then maybe something else can be just one layer above it. Okay. Yeah, okay. Yeah, that makes sense. You could just do that. Yeah, okay. So background is math dot huge. Okay. I'll have the chat up again. Let's move this back over here. Point origin. No, whoa, okay. The origin should always be. If it's always on top, let's default for it to always be on top, because that would make sense. Yeah, right now. Okay. Excuse me. What did I do here? I was copy and pasting that. What the hell? I did that twice somehow. Okay. There. Or math.huge. So then this one's always on top. Line now. Do point line. Z-index from 0 and then line group. Oh, I'm skipping over to add this down here. Do we do after the style or before the style? Before the style. Local z-index equals. Let's just keep this open right. Does he have this? And then this. After that. Okay. Do this to make sure we didn't break anything. L.new z-index, okay. Just going through each of these in turn. So the line group now, we're going to add z-index to that. We added it there. Now we have to add it down here in the print. And again, I'm trying to add them so that when you go to the print function, all of these are in order as they would be in other classes if they have the same thing. So the z-index is, wait, that should be before the color, right? Yeah. Z-index. Because z-index is, I'm trying to think like z-index is sort of an abstract, you're going from abstract properties of the object to more concrete ones. Like that. That's how I like to think about it. Class element length effect 2. So why is that there? Method. There. Instead of here. So stop. Okay. Line. default to that, but it should give you a vec2. Oh, that's right. Yeah, length of self.vec2s. That's right. Because I was actually getting directly the length of this, which is there is no length property if nothing is assigned there. But even though I was defaulting to having an empty, just a new vec in one, then I just had to put the self there, and that'll work. Yeah. Okay. I think this should go here under the length effect too. So move this for a second. Where is that? That's right there. Do that here. Now it's switched where they are. Okay. How are we printing colors? We'll mess. No. Wait, I did this in another. I did this in a line, I think, where I had a nicer way to print out the gradient. Yeah, there we go. Yeah, gradient equals nil. Local gradient equals self.gradients. And then we'll just do this gradient. This seems like repetitive code that I could just somehow deal with. Yeah. Okay, I know this is the super most interesting part. I'm thinking in my head what I want to do. I should be talking out loud about what I want to do. Because what this allows me to do is, in the line group, it would print out correctly the color. So that's the style. I'm gonna do style and then color. Oh, I'm already doing that. I'm already doing that? Is that the same thing? Oh, it is the same thing. Okay, it's just with different spacing. Okay. Okay, cool. Then don't worry about it, I guess. Okay. We're focusing on z-index now. Z-index. I think we're line, point, line index, and just the triangle now. Let's do triangle. Okay, I'm definitely not going to get. I'm not going to get to triangle today. I'm gonna do this. So z-indices to print statements. I did that. Look into caching for vec2. Okay. I'm sort of delaying moving on to triangle because there's so much to add to it, or so much like to refactor on it. I think I want to see like what is worth caching here. Okay, ostensibly some mathematical operations are faster than doing a lookup on a table. So what things are actually worth caching? Just division and other trig operations, etc. Square root, etc. It seems like molt and add root just be faster doing price. Okay. So we're asking GPT for items to insert operations and lookups can do play a role. Yep. We're doing standard Lua, I believe. I think we tried LuaJIT, but it didn't work. The exact same division many times. Okay. See, I was thinking about doing caching as a kind of exercise, like it doesn't really need it, like there's no performance bottleneck, but, and then I started thinking, when you're making visualizations, you can end up creating a lot of vec2s, and I think that actually might be a bottleneck. You might be able to squeeze out 1,000 or more extra vec2s if you optimize something, but the problem is, there's some overhead in creating a variable to cache it in the first place, and if you're doing that every single loop of the script, then you are you're balancing that between that and the actual operation you're caching, because if you're making a visualizer and things are always changing, then it's pointless to cache, because you just need to be updating the cache every single frame. But if you are doing something where things are more or less relatively static, then it can help to cache. So I'm talking myself into and then out of and then back into doing caching, and I just want to, I'm going to see if I can implement it and it doesn't break anything. Right. No, but I have to do an if check. no. Because you have to check every time. Okay, but then we have to have a check value. A check quality check incoming arguments to other deck. It's the same as it was when we cached it. So you're around two variables. The variable that the other represents the result. Yeah, actually, come to think of it, because you could potentially be multiplying the. There could be lots and lots of vec2 operations that you're doing, and if I went into each individual one that had a theoretical benefit from caching, division, square root, trigonomic operations, then if you were doing a layered versions of those transformations and stuff, that's just adding lots and lots of I think it's an interesting pursuit, but I would do it if I was certain that doing it wouldn't harm performance, because this is why people say that caching is a hard problem, because without any kind of profiler I would love to build some kind of profiler for this, because I really, there's no way to get, you can't really drive up the CPU of this thing, the timing, right? The timing is so, this percent is so inaccurate on the scale at which we need to be measuring this, that it's hard to know how much things actually take. So let's, for example, let's do this. Let's just, for the sake of an experiment, we'll cut this out. We'll cut this out, and we're just going to do the origin, which I don't think relies on any. No, it does. It does now. Forget it. I was thinking we could take out something and then see how much. Why not? We could just delete everything. Yeah. See, look, the CPU percentage doesn't go down. We put all of this stuff in here. Hold on. 17, maybe it goes up by 1%. Oh. Yeah, something like that. Oh, okay. Yeah, maybe 1%. It's hard to tell if that's just a random fluctuation here. I'm looking at this number here. Yeah, something like that. Maybe it's like adding a percent. That's not a percent of the total CPU. It's actually just a percent of this patch compared to this. So this timer node, that's all this timer node is doing is just counting up. It's like os.time or whatever. And then we're still using 0% of the CPU. So any of these kind of optimizations that we could add into here are essentially pointless. They would just be for me to practice doing caching. And again, if I was certain that this wouldn't harm performance, and it would just be a net 0 gain, then I would do it. But now I'm just thinking, no, I'll just skip that. So I'll do that, and I think that was an issue that I could just close. Caching. Hard to tell if this wasn't negative impact performance. So until I have access some profiler, I won't do this. Okay. Let's assign these all to myself. Okay. This stroke triangle is a surprisingly difficult problem. Because depending on the shape of it, you can't just inset a certain amount versus the centroid. You actually have to somehow inset these lines towards the centroid and then just draw them in between. I don't know. It's a thing. It's simple in concept, but it's not intuitive to what you think you would normally need to do. Okay. This would be fun. This is a website where you can define attributes. Basically, like in my ideal world, you'd be able to, I would have a website that was like a drag and drop editor, and then you can you can design the UI that you would have in audulus on the website, and then it would spit out code that you could just then copy and paste into audulus, and it would work based on this library. And in principle, this isn't too hard to do. You don't have to like each element in the website could be sort of a static thing, like you wouldn't be interactable. So if you had a knob widget, for example, that knob widget would just be a graphical representation of what that knob widget will be in audulus, and then the logic of this website would be placing the widget creation in the correct order versus the z-index or the layers that things are put in. But that way it would be like super duper simple to make a UI. You wouldn't even have to code. Like it would just be a zero code solution for this. And that's just a fun challenge that I set for myself to do at some point. Okay. Do I have any chats? Nope. Okay. Amy? No? Okay. Hi. It's my wife and kid are woken up. Okay, so I think that's enough for today. We fixed the origin point. What did we even do today? Did the origin. Yeah, z-index. Cool. That's enough for today. Okay, cool. Thanks for joining the stream, and I will see you guys tomorrow.